Hey there, computer science. A lot of you have asked me to go over a handful of these questions, actually, but I think the hardest one, I'm gonna share with you some of the other ones too, but the hardest one, it seems to be, is Mystery 4. So I marked this up, and I'll share this document with you along with this video. So here's the mystery method. And they have, once again, a nested for loop used for traversing 2D array A. So certain things to note about our 2D array. One is that if you look here, it starts at 1, normally start at 0, and then this less than symbol usually that takes care of the length. The last element not actually equaling the length. It'll actually always be 1 less, but then they end up subtracting an additional 1. So you have this buffer at the beginning and the end of the row. Same thing happens with the columns too. We're starting with column 1 rather than 0, and we're ending with 1 less than the last column. So you start with row 1 and you end with the second to last row, and when you're traversing the columns, you start with the first element, not the 0th element, and you're buffering the back. So in essence, I say over here, we're avoiding the first and last elements, and you can see why they're doing that buffer, because you're going to be accessing the left element and the ones above and below and to the right for each term. So they need to provide that buffer on the end. So another way to say that is really we're only traversing and assigning values here, and we're avoiding the perimeter as far as doing an assignment. We are accessing elements that are around that perimeter, but we're not actually changing them. So we're really going to just change that inner 2D array. Okay, so what I did here is I also noted what the summation represents. So it looks like if you just try to make sense out of each element call there, like for example, it says access the previous row by subtracting 1 and the previous column, right? So if we're starting with this element here, we're starting with 2. We're actually, if we go back a row and left a column, we're looking there, and we're going to be adding that to the row that's below and the column that's to the right. So those 2 red dots represent that sum. So it's kind of it's basically the adjacent elements on the descending diagonal, and then that blue summation does essentially the same thing, except that it's on the ascending diagonal. So we're we're summing the adjacent elements around each one. So what I did here on the iPad was it's kind of nice that I can do this with the highlighter. I went through, I rewrote everything over here, and I overwrote the summation. I guess I forgot to mention one thing. So then once you get those sums, now we have a simple conditional. It says if the first sum is greater than the second, assign the greater sum. Otherwise, or the greater sum to that element. Otherwise, if sum 2 is greater, assign sum 2. So pretty much whichever the greater sum is, you're assigning that to the current element. So for example, I just erased this yellow dot, but I'll put it back. So this is the first term. The first 2 sums are 4 and 3 is 7, and the other one is 5 plus 5 is 10. So which one would you assign? This becomes a 10, but it's really important that you overwrite that 10, because eventually that's going to be an element that you compare. So that's probably where a lot of you made a mistake. So we'll come over here, and you can see I just went through one at a time, and I used my little dots here to start. So I checked out, it's kind of hard to see. I mean, you could probably do it anyway, but so I went through and I compared, now it's interesting because it became a 10. You can see how 12 changed down there, but I went through each one here. You know what? I'll just show you over on this one. I went through each one and did the summation. So first it was that the 2 became a 10, Then I added the 4 and 9, that's 13, 6 and 7 is 13. So 6 just became a 13. And then 5 and 1 is 6, 2 and 4 is 6. So again, there's a tie, so 1 gets replaced with 6. Then when it came down here, you notice how the upper right blue dot is on top of that 6. Really, that's on top of a 13. So it's really important that you rewrote that. So actually, I saved the second one to do with you, and we'll see how it goes. So I'll show you how I did it, basically. All right. So we're going to start with this one, and so I'm going to white out the element in question. So we're going to have 0 plus 0 is 0, and 0 plus 0 is 0. So it looks like 0 wins this one. Okay. Then I'm going to white out the next element. I know this seems very, very clunky. And one thing that I should do, see if it lets me do this. No, it's not going to. And sorry. All right, just kind of put that there. So now we're going to compare 1 plus 5, 1 plus 5. We just get a 6 there because 6 ties with 6. You don't have to keep sliding the dots, but 0, 0, and 0, 0 again. So the 1 becomes a 0. 1 plus 5, 1 plus 5, 6. It's another tie. Obviously, if you're not using this technology, you just have to, I would just be rewriting the matrix as you go along. I'm calling it a matrix because it is. All right, so now we move on to the next row and repeat the process. So we have 6 and 3 is 9, so 9 is greater than 5. So we're going to replace that 5. Also, not that 5, the other 5. 2 plus 3 is 5. So we're going to replace the current element with a 9. Oh, I messed up. Okay, because I want to move my little dots around. So this current element becomes a 9, and then we move on. 0 and 2, 0 and 2. So the current element becomes a 2. 3 and 6, 3 and 6. Current element becomes a 9. 0 and 2 versus 1 and 2. So 3 is greater. So the 0 gets replaced with a 3. Yes, I'm going to make you watch all of this. You can skip through it. You can obviously speed the video up if you know what I'm doing, but this is for understanding purposes. And so we just did this. Now we're going to move on to the last row, starting at the beginning again. So we're going to compare 0 plus 1 is 1, 1 plus 2 is 3. So we're going to replace that current element with a 3. So you can see the importance of recording the previous rows because you're using those elements. So if you just look at the original matrix or the original 2D array, you're going to get incorrect results because this thing's dynamic. It's changing as we move along. So we have 4 and 9, 4 and 9. It's funny how that works out a lot. So here I could just make that into a 13. Okay. Then we have 2 plus 1, 1 plus 3, 4 wins that contest. Almost there, kids. And so some of you probably noticed that I didn't fully erase some of these. I'm sure it's driving you nuts. It's kind of bothering me too. All right. 9 plus 4 is 13, and 4 plus 5 is 9. Let's get rid of this 3 and replace it with the 13. And there we go. So I'm hoping that this is correct. So now I'm gonna nerd out, and I'm gonna actually type this in right here in my note-taking program. All right, let's get this pad out, and we have this. Let me grow this so y'all can see it. Okay, yeah, it's a little bit big. All right, and let's go. So if you notice the notation that I'm using too, this is just instantiating a two-dimensional array by literally writing out what the array would look like. So this is the first row is going to stay the same: 0, 1, 0, 1, 0, 0, comma 1, comma 0, comma 1, comma 0, comma 1. Right? It should be 6 elements. That's the first row. Comma. They want us to format it this way. It actually works. 2 0 6 2 6 0 6 1, comma, new row, 0 9 2 9 0 9 2 9 3 5. Yeah, I'm just gonna go insert commas. And then 3 3 3, comma 3, comma 13, comma 4, comma 13, comma 2. Last row stays the same: 1 4 1 4 1 4. Now this is how I see it. It's very possible that you'd be seeing this a different way. I'm going to jump over to the actual problem, and apparently I didn't do it right.
2 minutes later.
13. Please say that's it. Yes. Lovely. Small little mistakes. All right. Fantastic. Hopefully that was helpful.